What is that velocity? It is the change in position with respect to time. The gravitational force, it differs from poles to equator. There is difference in it. The velocity of one object with respect to other is said to be the relative velocity. Hello everyone, I am Brinda, Faculty of Physics, Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 4 of chapter 3, that is our motion in a straight line. So till now we have ended up till the equation of motion. Now it's the time to go for gravitation to check out the acceleration due to gravity. So now coming to the free fall, that is motion under gravity. Yes, the object has got motion under the gravitational force of the earth. So what exactly happens? That is, when a body is made to fall from the, when a body or an object is made to fall from the top, in the absence of air, the acceleration is same for all the objects in the absence of air. The body, before it reaches the ground, it acquires maximum speed, that is maximum velocity before it reaches the ground. So here it is all about a downward motion, acceleration due to gravity, which is measured in terms of g. So g is downwards, the gravity is downward, the pull is downwards, which is acting on a body. That is why whatever the object which is thrown upward will come downwards. So as you all know, the change in velocity is nothing but acceleration. So what is that velocity? It is the change in position with respect to time. So the change in position with respect to time is velocity, and the change in velocity, yes, there is change in velocity when the body is dropped from the top to bottom. So that is all about the acceleration, and this acceleration when an object is thrown upwards and it reaches downwards is that due to gravity. That is why we term it as acceleration due to gravitational force, that is acceleration due to gravity. So when a body falls vertically downwards, there is change in velocity, and that is termed as acceleration. And acceleration is due to gravitational force, that is gravitational force of earth. Therefore, it is termed as acceleration due to gravity, whatever I had told you. So next is, it is represented by G. So this is very important, students. The gravitational force is always represented by G, that is acceleration due to gravity. So now, the value of G is high at poles. The gravitational force, it differs from poles to equator. There is difference in it. So what happens exactly? That is, the gravity near the poles is said to be higher. The gravitational force is high at the poles. So that is all about 9.83 meter per second square. The value of acceleration due to gravity at poles is said to be 9.83 meter per second square. And value of acceleration due to gravity, it seems to be low at the equator. At the equator, the value of acceleration due to gravity seems to be less. You can just follow up with the image. Okay. So the value of acceleration due to gravity is high at the poles, and the value is 9.83 meter per second square, and the value of acceleration due to gravity is low at the equator. So its value is said to be 9.78 meter per second square. But approximately we are considering it as 9.8 meter per second square. This is a standard unit what we are considering for acceleration due to gravity, that is 9.8 meter per second square. This is what you have to remember. So for freely falling body, the acceleration due to gravity is positive. For the freely falling body, the acceleration due to gravity is positive, and for the body which is thrown upwards, that is against the acceleration due to gravity, it is negative. So you all got to know how exactly it is. So when coming to the previous slide, when the object is thrown downwards, from upwards to downwards, it is acting along the acceleration due to gravity. So whatever the freely falling body from upwards to downwards, whichever object is falling upwards to downwards, it is considered to be positive. If the object is thrown upwards, that is against the acceleration due to gravity, then the acceleration due to gravity is termed as negative. It is negative. So now we have got distance traveled during nth second of motion. So we have to consider a body which is starting with initial velocity, which is termed as u, and moving along a straight line. A body which is starting with the initial velocity, that is u, it is moving with a straight line. So with the uniform acceleration of a, the acceleration is nothing but a. So you have got initial velocity as u, it is moving in a straight line, and it has got the uniform acceleration as a. So let S1 and S2, those be the distance which is travelled at n seconds as well as n minus 1 seconds. Remember, a body, it is starting with initial velocity, and that initial velocity is termed as u, or it can also be termed as v naught. And it is moving in a straight line, having a uniform acceleration, that is, the change in velocity is uniform. There is change in velocity due to which acceleration is termed, but it is uniform. So change in velocity is uniform. So it is a. Let S1 and S2 be the distance travelled at n seconds and n minus 1 seconds. It is not just second, it is seconds. So if Sn is the distance travelled by the same body in the nth second, we have to find out what exactly is that distance. So Sn is equal to S1 minus S2. So you all know that equation of motion which terms as S is equal to ut plus half at square. So here they have asked t is nothing but nth second. That is the nth second. So what are we supposed to do here? That is u into, in place of t, you're supposed to represent n, plus half a n square minus, you have got again S2, that is your S2, it is moving in n minus 1 seconds. So my n minus 1 seconds can be replaced as, so u into n minus 1 plus half a n minus 1 the whole square. So solve this, which is equal to un plus half a n square minus, it is un plus u minus half a n square plus a n minus half a. On solving this, you're getting this equation. So your un cancels, plus half a n square and minus half a n square cancels, because same numbers and different signs, it gets cancelled. So what remains is Sn is equal to u plus a n minus half a. So in order to remove this, so it is Sn is equal to u plus a by 2. So we have got 2n minus 1. So this is the equation for Sn, that is distance travelled during nth second of motion. What is the equation? That is Sn is equal to u, that is initial velocity, plus a by 2 into 2n minus 1, where a is the acceleration and n is the nth second, whichever it's taking up to travel. So next, relative velocity. So what is this relative velocity? The velocity of one object with respect to other is said to be the relative velocity. Relative velocity means it is the velocity of one object with respect to the other object. So there is a relativity, right? If a vehicle alone is moving on the road, so the frame of reference what we consider will be the road. So with respect to that road, what is the velocity of a vehicle? So for example, here you have got a ball as well as train. So this ball is also moving as well as the train is also moving. So only if a train was moving over here, what it would be? It would be like relative velocity of train with respect to the track, right? So now a ball is also in motion along with train is also in motion. So relative velocity of train with respect to ball is given as v ball minus train. So in train point of view, we are checking the relative velocity of the ball. Similarly here, relative velocity of train with respect to ground. So ground is said to be the frame of reference. According to ground's point of view, we are checking this, that is ground, that is relative velocity of train with respect to the ground. Similarly, simple example, so if this is an object A and if this is an object B, and object A is moving as well as object B is moving, both are along the same direction. So with the view of B, that is with respect to the view of B, that is relative velocity of A with respect to B. So it can be given as VR is equal to relative velocity of A with respect to B. This is how it goes, and it is in the same direction. If the objects are in opposite direction, the same thing happens, but the sign changes. That is relative velocity of an object with respect to B, that is relative velocity of A with respect to B is given as. This is how it goes. That is all about the relative velocity. So in today's class, we have studied regarding the free fall, that is acceleration due to gravity, the motion of a body under the gravity. And when the object is dropped from top to bottom, that is, it is acting along the direction of gravitational force. So it is positive acceleration, that is, it acquires maximum change in velocity. When the body is thrown upwards, the acceleration due to gravity is acting downwards. So there is opposition. So the velocity decreases. So when the velocity decreases, what happens? The acceleration due to gravity becomes negative. So it becomes minus g. Okay, and also you have studied the gravitational force at the poles as well as equator, why it is greater at poles and why it is lesser at equator. Greater at poles because the poles are very near to the center of the earth. At equator, the gravitational force decreases, that is because it is away from the center of the earth. Okay, and other one is the gravitational force is acting towards the center of the earth. That is all about your gravitational force and the acceleration due to gravity. We checked about the distance, that is distance of a body in the nth second. How to calculate the distance of the body in the nth second, that also we just derived an equation and we got the equation to calculate the distance of the body at nth second, as well as we went to the relative velocity. So what was there in relative velocity? It is the velocity of two bodies. We checked the velocity relations of the two objects. So relative velocity, it is the velocity of one object with respect to the other. So when it is along the same direction, how we calculate the relative velocity of two bodies, and when it is in opposite direction, how we calculate the relative velocity of the bodies. So let us all meet in our next class. Until then, thank you. Have a good day.